Hey guys, welcome back to my channel, The Neat Way to NEET. Don't forget to like and share the video, and if you are a new visitor, please do subscribe the channel. This is the second video of the Revise With Me series. If you haven't watched the first one yet, I'll link it down in the description box. You can check it out from there. Today's video will be about 3 graphs of kinematics. So without further delay, let's get started. Displacement time graph has displacement on the y-axis and time on the x-axis. So when we draw the graph, the slope of the graph denotes velocity. Why? Because velocity is rate of change of displacement with respect to time. And the slope of displacement time graph gives us exactly that. So if the graph is a straight line parallel to time axis, then slope would be 0. That means velocity of the body would be 0. If the graph is a straight line inclined to the time axis, it shows that velocity is constant. That means body is moving with a constant velocity. This was about when the graph is a straight line. But when graph is curved, if we have to find velocity at a particular time, then we take tangent to that point and we calculate slope of that particular tangent. If graph is curved, then tangent would be different for every particular time. That means velocity is changing for that particular body. There are two possibilities in the curved graph. First is if the graph obtained is a curve like OD whose slope decreases with the time, then the velocity goes on decreasing. That means the motion is retarded. And the second is if the graph obtained is a curve like OE whose slope increases with time, the velocity goes on increasing. That is, the motion is accelerated. The second graph is velocity time graph. As we know, the rate of change of velocity with respect to time is acceleration. So, the slope of velocity time graph would give us acceleration. First condition is when the graph is a straight line parallel to the time axis. Here, slope would be 0. So, acceleration would be 0. That means body is moving with constant velocity. Second is if the graph is a straight line and inclined to the time axis with positive slope. It means that the body is moving with constant acceleration, which is positive. Or if the slope is negative, it means that the body is moving with constant acceleration, which is negative. That means the body is retarding. If the graph obtained is a curve, find the acceleration the same way we found velocity in the displacement time graph. That is by drawing tangent for the particular time. This time also we have two situations. First is if the graph obtained is a curve like OD whose slope decreases with time, the acceleration goes on decreasing. Or second, if the graph obtained is a curve like OE whose slope increases with time, the acceleration goes on increasing. We can find the displacement of the body by calculating the area under curve of velocity time graph. Third is acceleration time graph. When the graph is a straight line and parallel to time axis, then the acceleration is constant. When the graph is an oblique straight line having positive slope, then acceleration is uniformly increasing. And when the graph has negative slope, then the acceleration is uniformly decreasing. For uniform straight line motion, acceleration is 0. So velocity is constant with time. So for uniform motion in a straight line, the graph of velocity time would be straight line parallel to the time axis. And as the velocity is constant, so the graph of displacement time would be a straight line inclined to the time axis. But for motion with uniform acceleration, the acceleration time graph would be a straight line parallel to the time axis. Velocity would be increasing constantly. So velocity time graph would be a straight line inclined to the time axis. And velocity is not constant, it is constantly changing. So the slope of displacement time graph has to change constantly. That means displacement time graph would be a parabola. These were few conditions which you need to remember. Now let's see questions. The first question is the velocity time graph of the motion of a car is given below. Find the distance travelled by the car in the first 6 seconds. Velocity time graph is given in the question and we need to calculate the distance travelled by the body. As we know, in the velocity time graph, we can calculate distance by finding the area under the curve of the graph. Here we can calculate the area by dividing the complete area into two parts. First, a triangle ABC and second, rectangle BDEC. Now by applying the formula of area of triangle and area of rectangle, we can easily find the total area under the curve and therefore distance. Area of triangle ABC would be half into 2 into 3 into 10 to power 3. And for area of the rectangle BDEC, we have one side as 3 into 10 to power 3 and second side would be 6 minus 2, that is 4. So area of rectangle would be 12 into 10 to power 3, which gives us total area of 15 into 10 to power 3 centimeter, which is equal to 150 meter. Second question is, indicate the velocity time graphs for a body when it is falling under gravity. As the body is falling under gravity, we know the acceleration of the body would be g, which is constant. That means Vt graph would be a straight line inclined to time axis. And if we take downward direction as positive, then the slope of graph would be positive. Follow these conditions, then we would get the Vt graph, which looks like this. Second condition is body is thrown vertically upwards till it falls back to the ground after reaching the highest point. As the body is thrown, that means it would have some initial velocity. It is reaching the highest point and then again falling back to the ground. It reaches the highest point, the velocity has to be 0, which would again increase when the body fall back to the ground. So we would get the graph in which we would have a value of v for time equal to 0, which would keep decreasing till it reaches the highest point. It would be 0 at highest point and it again would increase, but in the negative direction when the body starts falling back to the ground. So our graph for the given condition would look like this. So that's it guys. I used to face a lot of problems in these kinematics graph back when I was preparing for my NEET exam. So I thought about making a video on this particular concept. If you have some topics which you particularly find difficult, please do tell me in the Instagram DM or in the comment of this video, and I'll try to make videos on those topics too. If this video helped, please do like the video and share it with your friends. Don't forget to subscribe the channel. Till we meet again, happy learning. Goodbye.